Hello everyone, I am Varodaiah and I am here to present a EV and ADAS project. EV adoption increases demand for advanced driver assistance system ADAS. Embedded system provide low latency sensor processing and safety critical controls. This project builds the affordable simulator for ADAS development and testing. The problem statement includes a lack of low-cost, accessible EV safety simulation platforms for education and early-stage development, need for software-driven ADAS testing without full vehicle hardware, real-time monitoring and deterministic fault detection, and difficult prototype affordability. This project helps us in detecting forward collision warning, blind spot detection like left and right, and we shall also use alarms and LEDs with buzzer. If the time to collision is less than 5 seconds, warning alarm is displayed, and if it is less than 2 seconds, critical alarm is displayed in the EV dashboard. The main motto of this project is to detect obstacles using ultrasonic sensor and trigger collision warnings, estimate the state of charge and SOC and motor temperature, and display it on Python dashboard using UART protocol, universally asynchronous receiver and transmitter protocol. We use virtual terminal to print the status of the ADAS, and we use EV dashboard to display the animated version of ADAS like speed, SOC, torque, collision, alarm type, whether it is advisory, critical or warning alarm, and also bird eye view perspective is used in this project. We also use Terraterm instead of virtual terminal by setting the baud rate to 115200 and setting COM port using BSPE. The components which we use in this project is STM32. The full name is STM32 F103CE8T6 and the board name is Blue Pill, which is a microcontroller for time sensor processing and control. HCSR04 is the ultrasonic sensor which is used to detect forward collision warning and blind spot detection. We also use LEDs in our project, buzzer and potentiometers, which is 0 to 3.3 volt. UART protocol is used to interface the Python dashboard. So we use software stack like STM32Cube IDE, and HAL Hall is the built-in function which is used in the code, and we use Python dashboard to display the time graphs, logs and control panel using PY serial and plotting libraries which we use in Python version 3.14. PiximLab is used for hardware test, and Terraterm or VSPE which is used for serial comms and debugging. So this is the system architecture: sensor, STM32 microcontroller, EV control algorithm and ADAS module. So here we use the sensor, ultrasonic sensor which is used to calculate the distance, and ADC which is used to convert 0 to 3.3 volt to 0 to 4096. The speed is estimated from wheel encoder and updated in EV. ADAS logic, collision and blind spot checks every control loop over prioritized alerts. Telemetry which is UART. We just connect PiximLab to one port and Python dashboard to another port and display the values. Software modules: EV controller module which is the state estimator and drive mode manager, ADAS module, collision detection, blind spot logic and alert arbitration, ultrasonic module, low latency echo timing and filtering, UART shell, command interface and telemetry framing, fault management, threshold monitoring and logging and graceful degradation, Python dashboard visualization, replay and fault injection controls. Let's see the key features, which is real-time monitoring of distance, state of charge, temperature and vehicle state, collision warning with graded alerts, blind spot detection using multiple ultrasonic beams and logic fusion, drive modes which is normal, sport and eco. Eco which gives maximum range, normal which gives general driving, sport which gives performance and overtaking 200 nanometer, whereas eco gives 120 nanometer. Live dashboard is shown with telemetry graphing and CSV export. This is the EV dashboard which you can see. Now I shall give the project demonstration. Opening STM32 Cube IDE Mm, something is glitching. Just the IOC file is loading. Yes, it's loaded, and these are the connections as I have shown here. Next I go to ultrasonics and I click on core, and I have inc file and source file. To create header file, I just need to right click and select new and go to header file. And if I want source file, the same thing, just right click, go to new and select source file. So you can see how much files I have enlisted in my project. So I go to system core and select RCC file and set high speed clock HSC to crystal ceramic resonator, and I go to analog and set ADC1, and I just give ticks to IN0 to IN3, and next I go to timers. I set 3 timers, time 1, time 2, time 3, and I do not use time 4 here, and I set time 1 prescaling value to 71 and time 2 prescaling value to 0, and time 3 I set it to 7199, and I go to connectivity and select USART1 and select the mode to asynchronous mode. So as you can see, these are the files which I have implemented in my coding, and I shall show you the sample code. So this is the coding part which I have implemented here. Okay, next I will open Pixim Lab. Loading. Monitor is slow. Okay, I will go to file and just load binary file. So as you can click binary file and it's loading. So you can see the virtual terminal on the left side. So I shall just increase the potentiometer values. So I am changing it. So as you can see here live, yes, when I increase the value, the speed of the ADAS dashboard just increase. So you can see, wait for a second, yes, you can see that the alarm is blinking. Okay, that's it. Now I want to go to file and just click configure and set it to COM7. Serial port is set to COM7. Yes, and now you can see this. Okay, you can see the EV ADAS values. Going to file explorer, clicking on this PC, yes, OS and new folder, new folder, and Emertex embedded internship Python file, and this is a Python file as I want to show you. Yes, and now it is loading. Yes, you can see the EV dashboard here, and this is the speedometer which is displaying the speed, and you can also see the EV dashboard which is printing the SOC value. So the battery percentage is just 79 now, and you can also see the graph which is in the left side. Okay, you can also see the ADAS bird eye view in this project. You can see that the EV and this is decreasing. Yes, and now the time to collision is also decreasing. It's 0.1 second. The speed is also increasing. Yes, you can see the blind spot right. Yes, and it has shown the alarm advisory. Okay, yes, the values are changing, the speed is increasing now. Okay, the battery percentage is also decreasing, and if we apply brake due to negative torque, regenerative acceleration will occur, and This will increase the state of charge, which will increase the battery percentage. Yes, and this is the project. Yes, thank you.